Thank you, and good afternoon. It's great to be here today. I learned so many things today about cooling. I haven't heard before. Some I did, and I think we have a great opportunity to collaborate here. So let's go a little bit into the basics. I want to talk a little bit about how can we reduce carbon footprint. How can we work together to make that happen, yeah? So Indonesia has an interesting carbon footprint, 817 grams per kilowatt. It's already down, yeah? Used to be more than 900. Then I checked a bit in the region, since we have so many countries represented here. Philippines is about 581. Australia 560, Malaysia 540, Japan 480, Thailand 477, and Singapore is the lowest with 405 grams, yeah? So that's a pretty big carbon footprint. World average is around 460 grams, yeah? Singapore is leading, even though it has the smallest renewable content when you look a little closer, with only 5%. That's increasing now because they're importing more. Solar, we know in Southeast Asia, is just limited because we just don't have so many sun hours as in the desert. And that's why we are looking at captive power. We heard earlier already the problem with hydrocarbon-fired power generation is it's very dirty, yeah? So very common is coal in the region. It's cheap. Everybody loves it because it has the lowest cost for production. Clean coal, it costs a bit more, but also is way high up there. Then you have your liquid fuels. Then you have gases. You have the open cycle gas turbine. Then you have the gas engine. Then you have the combined cycle gas steam turbine, which is leading. But when we look at decentralized captive power, and we put it in a combined chilling, heat, and power solution, you get actually the best output all over here. So, and that is then around 250 down to 200 grams per kilowatt. And that's where it gets interesting, because when we remember the figures before, that means in Indonesia, an industry who is implementing that can cut the carbon footprint by up to 75%. In Singapore, which is the best in the region, you can cut your footprint up to 30%. So it is still a viable solution, because when we look at the industries, if we can now reduce 70 or 30%, it's already a big step. A big step that will help the environment. And the most interesting part is, most of the time you can save significant money with it. So, rethinking the captive power means not only on-site power generation. Advantage is no grid losses, no transformer losses, and, as I said earlier, you get a much higher output because you're producing the power where you need it. So you're not only using the electricity, you want to use also the heat that comes with it. And what we have here is we have natural gas replacing normal Tier 2 diesel engines. 25% CO2 reduction, 90% NOx reduction. We can use biogas, biomethane, and other renewable fuels, which brings it down to zero. You can we can then go hydrogen-free, carbon-free fuels like hydrogen, as the colleague just said, and of course also biomass-fired boilers, biocrops, and so on. So all this can be brought into the equation. We just have to look. Every country is different, every region is different, every industry is different. tailored CCHP solutions. What is CCHP? I mentioned it earlier, and I think a lot of you know it. It's combined chilling, heat, and power. So what do you need? You need a prime mover, you need fuel, you need a generator, then you get electricity and you get heat. In case of a gas engine, you have an exhaust, which is high temperature, and then you have your normal water cooling for high and low temperature, which is normally going to the radiator, coming from Güntner, of course. So, what can we use the heat for? So we talked a lot about data centers today, so I will just skip through here. Of course, process water heating, steam, thermal oil heating, absorption chilling. We will go a little bit more into it because I think, yeah, everybody talks data centers. That's the big business at the moment. And then we have drying processes, whether it is for ceramic industry or food industry and others. We can discuss in detail for each industry. And then we have the liquid desiccant, which I prefer to the desiccant wheel we saw earlier. Why? Because you can already use 60, 70 degrees jacket water to boil it out. So it is a low temperature solution. The desiccant wheel normally needs 12 to 16 bar of steam for drying it out. Yeah? So here we have then the opportunity to dry it out with 60, 70 degrees jacket water, and that's just perfect. So that's to summarize. We have here combined cycle. That's your efficiency range, depending on which load you're running. Then you have the internal combustion engine, and then you have your CHP solution or CCHP solution, which brings you down already to below 250 grams. And we said already earlier, the big changer here is then, some examples. Yeah. I flipped just through it, yeah, because limited time. So we have process water on one side, everything coming out here, 90% efficiency, 222 grams. We have steam and chilled water with the jacket water. It's actually the most common one in Southeast Asia. We installed, I think, 9 sites with that. So this is most often used in industry, especially when they need steam, and then the jacket water they cannot use, then they go in an absorption chiller. And then we have everything into cooling. So, and that's the one I want to talk a bit more about today, because we can reach here 81%. The cooling output you get from jacket water plus exhaust, or I prefer steam chillers, gives you 81% overall energy efficiency. With a chiller COP of 5, that would be about 53% electric efficiency when we calculate the electricity savings of the chiller. That puts you in a range better than a combined cycle power station. Yeah? And the interesting part is it really fits the chilling demand of the data center. 10 megawatt IT load is a perfect fit because you get your 10 megawatt of chilling out of it, rule of thumb. So electric output is equal chilling output. It varies a bit depending on the engine model and depending on which level you're running it. And that brings us very close to everything. Yeah? So when we use absorption chillers, if we run on a higher delta T that we can use with air-cooled absorption chillers, then we also take out the water wastage. And data centers can not only reduce their PUE, which at the moment we heard also earlier is around 1.5, 1.4, 1.5. In general, we can bring it down to 1.25 to 1.28, depending on how the chilling system is integrated. And that's 20–25% energy savings for each data center. Even the existing ones can retrofit that. Yeah? The big blocker at the moment is nobody really likes to invest into their own captive power. Luckily, in the US, With the AI drive, they are now starting to purchase their own power. Unfortunately, they don't do it in a CHP or CCHP solution, but if you consider it, then it is a complete game changer because it reduces your power consumption, and as such, it reduces your OpEx considerably. We ran calculations in countries like in Singapore, simple return less than 5 years, and then we start talking. In other countries, we came to simple returns of about 3.5 years. So it makes sense. It's proven technology. It's not something new. The first solution with a Type 6 engine with the 620 in Jakarta was installed for a shopping center that was installed in 2007. So almost 20 years ago. Yeah? So it is existing and it works. So, and now we can go even a step further, as we heard. Jenbacher has a vast portfolio. So we go from 300 kilowatt to 4.5 megawatt. Everything comes also in a box if you need it. But the big advantage of Jenbacher is it can burn more or less any gas which has a good heat rate. Whether it's pipeline gas can be mixed with other carbon neutral or carbon free gases. Difference between carbon neutral and carbon free is one is derived out of an organic process, the other one is not producing CO2 when it's burned. So, what does that mean? So, we can use biomethane. Biomethane comes in many forms. In Indonesia, mainly the biogas comes from palm oil industries. Starch industry has big digesters where we have biogas. There is some landfill, could be more. And that is then either directly converted on site with a very high CO2 content, or you take out the CO2 and put it in a pipeline. Hasn't happened yet in Southeast Asia. We have been told next year Osaka Gas will start injecting biomethane in the Sumatra pipeline grid with a goal of about 5 billion BTU by next year. So we already have a precedent. We will get biomethane available. So there is a mechanism. They put a flag on the molecule. That means you get then from the supplier the voucher confirming that they injected this amount of gas into the pipeline and that you're getting it. Another form of capturing CO2 is greenhouses. In Holland, it's quite common. What they do is they take the exhaust of the gas engine, they clean it, and they pump it into the greenhouses, helping them to grow the produce much, much faster. So it's one of the ways. And of course, then you have hydrogen and CHP solutions, whether it's for commercial or industrial sector. That's the last part. Yeah? And of course, biogas directly. In Indonesia, about 40% of all Jenbacher gas engines running on biogas. And this is also our continuous business here, yeah? And we also do the biogas installations in Indonesia, in Singapore, where we also have now a project with the government there. So it is, Jenbacher in this case is number one. Even more important is for clients when they invest, yeah, you don't want to have a stranded investment. You invest today in a machine and tomorrow you cannot use it anymore because regulation changes, the fuel changes that you get and so on. Jenbacher gives you the possibility to use any fuel. And that can be in form of, we can use 2 gas trains and mix it directly at the engine, your 2 fuel gases, so you have a natural gas. You have, for example, an anaerobe water treatment system in your plant. We can take the biogas and inject it here directly, mix it directly at the engine. We can receive other gases in liquid or in gaseous forms, like, for example, bio-LNG, mix it in. It's possible. And if you have an engine that is already 15 years old, we can retrofit it, we can convert it, we can upgrade it, and you can still do the same thing. Yeah? So you're not stuck. You're not stranded in an investment. Next thing is, it can be pre-mixed, as I said earlier. So we hear already that more and more companies are looking into injecting biomethane in the pipeline grid here, which makes it then available all over Indonesia. But there's also already discussions with Singapore government to have a similar cooperation and mechanism to put the flag on the molecule so that the biomethane here can be also delivered in Singapore. Then we have the possibility of injecting hydrogen. Yes, everybody talks still about hydrogen. The big problem is hydrogen is expensive. As much as we like green hydrogen and blue hydrogen, it's just at the moment the cost is way too high. Yeah? But we are ready for it. We can convert anytime, as the colleague already said. It's just a bit more difficulty to mix it in, that's all. And it goes both ways, pre-mixed or mixed directly on site. And then that's your footprint, yeah? And that's your plan. You start from the grid, you go to your internal combustion engine with a CCHP plant, you reduce your carbon footprint right away. In Indonesia, 70%, Singapore, 25–30%. And then as carbon-neutral fuels become more and more available, or carbon-free fuels become more and more available, you start blending them in and you start using them, reducing your carbon footprint. But not only reducing your carbon footprint, also reducing your OPEX. That's the most important, yeah? Because Singapore, for example, has a very high carbon tax already. In January, they will go from 25 Singapore dollar per ton to 45 Singapore dollar per ton. 2 years down the road, it will go up to somewhere between 80 and 120, they said. So then, when you have biomethane available, which there is already 2 suppliers in Singapore as well, around $30 the MMBTU, you get a simple return within 3.5 to 4 years. So you can reduce your carbon footprint now and save money. Yeah? So no more excuses. We don't have to just talk about it. We can really do something about it. And of course, as the previous panel already discussed, we have to start managing our energy sources. Yeah? For that, Jenbacher developed already a microgrid management system, but we're also going a step further. We have cooperations with university in Indonesia, as well as the University of Singapore, where we look into not only microgrid management systems, but also beyond that. So that includes cloud monitoring, storage and grid management, power wheeling, fuel management, what fuel is available, LNG, bio-LNG, biogas, biomass, what fuel is available, what is the price, how do we utilize it. Then we have our energy sources. Beside the prime movers, we can have photovoltaic, we can have wind, no, not so much here, but only in certain areas. And of course, then we have storage. And then we look at our heat demand on site, and then we mix. We can have standby boilers or main boilers on biomass, whether it's for low or high pressure steam. We can go to natural gas, we can go to biogas, and all the other sources we have. So normal algorithm already exists. With the future of AI, when you bring that then in the mix, of course, you can much better optimize all these parameters and bring them to bear to really minimize your OpEx and maximize your carbon footprint reduction. Well, that is it. If you have questions, please feel free to contact me. Thank you.